This is Alan Dupree from MacDac Engineering. We're going to look at Mastercam Solids today. As you notice, we can bring in a variety of solid models from Pro E to Step, SolidWorks, Inventor. We'll just bring in a SolidWorks part. It will bring in assemblies. We can bring in solid surfaces, edge curves. We can even import solid history from SolidWorks. When we bring in a solid, we have the ability to rotate it. We have the ability to translate it from one position to another or one plane to another. We have the ability to mirror it in any axis. We can even scale it. Without the solids option, we cannot use those functions. We don't have the ability to rotate it. We don't have the ability to mirror it, scale it. We have to use our world coordinate system to move from one position to another. We can bring in surfaces, but it's better to work off solid models, as you'll soon see. So I brought a model in. We're going to set our stock. We'll set our material to aluminum. Calculate our feeds and speeds off the material. We use feature-based milling. We'll just look through the parameters. We have our tooling. It'll pick and select. We have our toolpath parameters we can predefine. And now it's performing feature detection. You can see it producing the toolpaths on the left-hand side in the operations manager. And you can see the toolpath being applied inside the part. Feature-based machining creates three types of toolpaths. Starts with a roughing toolpath, moves to a rest machining toolpath to clean up the corners, and then it completes it with a finished toolpath to clean up the walls and floors if needed. We can also do feature-based drilling. It'll find blind holes, through holes, chamfers, counterbores. It'll circle mill. We simply go to hole detection. It determines the hole, the diameter, the plane, where it is in a z-axis, the depth, if it's a counterbore, countersink, and selects the tooling appropriate to the type of operation. We can select any drill and turn it into a right-hand tap, left-hand tap, reamer. When we pick a tap, it will select the tooling for it, center drill, number 7 drill, quarter 20. We can also select another drill and turn it into a reamer.
Okay, let me look into it and give you a call back or whatever.
It will produce all the tool paths for the drilling operations. As you notice, we have spot drilling, we have reamers, taps, end mills for circle milling. We created 53 operations. automatically right off the solid model. Now in verification, we can see exactly how it cut. And you can see the various end mills that are being used as it roughs out the pockets, machines the outside of the part. Does all the drilling, tapping, spot drilling. It'll even do the circle milling. And there's the circle milling coming up. It'll helix into the part, into the material, and spiral out. And it did create 53 toolpaths. That is one benefit of working off solid models. The next toolpath we're going to do is dynamic area. The other advantage of working off solids is you simply select the faces you want to machine. No shading. Select the tool. No stock on walls or floors. Put a depth cuts on, 1/2 inch. Depth is set to incremental 0, that'll work off the floors of the solid model. All the toolpaths are created for cutting the pockets. The other nice thing about solids is it can bring in the solid model into the verification software. Then you can see if the toolpath is violating the solid model in any way, or if there's material left over. The next toolpath we're going to do is dynamic core. We can work off geometry or solid edges. Simply select the edge. Then go into the toolpath parameter page. Select the tool. Remove stock. Put it at 0. Controlled by the depth of the geometry or the solid model. We'll select all the tabs that we want machined. They're all various depths. Simply click the faces. And select edges or faces you don't want machined. Set at incremental, all the depths are set. And we'll look at toolpath verification on this part. This is dynamic milling toolpath. Uses the side of the end mill. Great toolpath that never violates the amount of material taken off. If you put 30%, it'll maintain 30% everywhere on the part. The roughing was done in 2 toolpaths. And I'm working right up to the solid model. You can turn off the stock, and you can work right off the solid model also for easy verification. The advantage of solid models is shading at various depths. If I want to do a simple contour around those edges, I could create edge curves like I did here. And the depths are controlled by the solid edges or geometry edges. It's much easier to see what's going on when you work off a solid model because of seeing the depths and where the toolpath is located upon the part. So there's many reasons for working off solid models. Here's a few more coming up. The other benefit of working off solid models, it allows you to modify the model itself for toolpath operations. We're going to do a simple parallel toolpath here. We'll use a 1/2 inch ball. I'm going to select the face. As you notice, it did plunge in or retract over the faces. With parameters, we can stop that, or we can modify our solid model to make it easier for machining purposes. And we could just reapply that toolpath to this new face. With a solid model, we can analyze. We can select any fillet and determine what size it is. Those fillets are 0.122. We would like to use a bull end mill with a 1/8 inch radius. So we're going to suppress some of the holes. Find features. We have found the fillets now. It detected 94 fillets. It is 122. We'll change it to 125. And the solid is now updated. We'll change this fillet to 200. As we hit regen, you can see the fillet change. We could also suppress fillets also to remove them from the model. Other functionalities we have is we can do a solid layout, which will project our part in various views: front, top, right side, isometric. We could add section views. We'll do a horizontal section view. We can do a detail view. We could dimension right off the geometry we created. Horizontal, vertical, angle dimensions. Simply select the lines. We could do radiuses, fillets, holes. And we could apply toolpaths right to this 2D geometry we just created. And we can see the toolpath following the profile we selected. Now we're going to create a simple model. Create a rectangle. We'll create another rectangle for the middle and two other rectangles on the side. We'll now go into solid modeling. We'll extrude it 1 inch down to create a body. We'll extrude the two rectangles to create a pocket. We don't have to go through the drop down. We could use icons if we wished for easier access. We could extrude in any direction. We're going to add a boss. If you notice there is draft. We could apply if we'd like to. We're now going into filleting. We could just select a face and it'll fillet all the edges. We'll put 125. We'll create another fillet on top of 0.250. And we'll select the bottom faces of the pocket and we'll add an 1/8 inch fillet. Now we could also shell. We have lots of tools available in Solids. Select the face we want open. We could shell inward, outward, or both directions with different values. We can delete an operation, such as the shell. Now we'll create a rectangle. We'll extrude it 3 inches up in the air. Now we'll remove our part and we'll have a cavity for a mold.